Hello guys, welcome back to the channel. Today we're going to solve this Leetcode question which is find the town judge. So now let's go through the question. In a town there are n people labeled from 1 to n. So uh, there are n people whose numbering is from 1 to n, and there is a rumor that one of these people is secretly the town judge. In these n people there is one guy who is a judge of the entire town, right? If the town judge exists, there may not be the judge. If the judge exists, the town judge trusts nobody. This guy never trusts the rest n minus one guys who are in the town, and everybody except the town judge trusts the town judge, right? So all these n minus one guys will trust this guy, but this guy never trusts any other guys. So and there is exactly one person that satisfies the properties 1 and 2. So this says that there can be only one judge in the entire town. So we're basically given an array trust where trust of I equals to array of ai comma bi, representing the person labeled ai trust the person labeled bi. If a trust relation basically says, we're given a trust array. In this, we'll have subarrays, and in each subarray, we have A and we have B. This means an array A comma B means A trusts B, but B does not trust A. It doesn't mean B doesn't trust A. It only means that A trusts B. So this is the question. So at the end, what we need to do is we need to return the label of the town judge. We need to identify who the judge was in the town if the judge exists, or return -1 otherwise. If in this town, if there is a judge, we need to return him, else we need to return -1. So we need to do this. So let's try to solve this question. The first idea that came into my mind after reading this question is that what I'll do is, I'll take a judge variable. Oh, before that, let's look at these examples in order to get a better idea. We are given n as 2, so there are two people in the town, and there is a trust array. In this trust array, it is given that one will trust two, right? So this means that there are only two guys, and one will trust two, but two is not trusting anyone. So two is the judge, right? Here it is given that all the persons other than the judge will trust him, but the judge himself does not trust anyone. So it is getting satisfied, right? And in this example, there are three people, 1, 2, and 3, right? So here one is trusting 3, one is trusting 3, 2 is also trusting 3, but 3 is not trusting anyone. So 3 is the judge. So in this example, we have three people. That is 1, 2, and 3. Here 1 is trusting 3, 3 is, 2 is trusting 3, and 3 is again trusting back 1. So we see that the rest of the people are trusting 3, but 3 is trusting another one. A judge trusts nobody, right? So here 1 is trusting, 2 is also trusting, 3 is also trusting. So none of them are judge. So we need to return -1. So this is the explanation of the example. So I hope you got a clear idea of question right now. So let's try to solve this. Now, when I first saw this question, the first thing that came into my mind is that, I'll have a judge variable. I'll mark it as -1. Mark it as -1. And what I'll do is, if let's take this example, or let's take this example. what I'll do is, here 1 is trusting 3, right? So what I'll do is, the one uh, the one who is getting trusted, uh, just a second. Suppose, let's say we have this example. Initially, our judge is -1. So what's my basic idea is, initially in the first array, there will be a person who will be judging the right person, right? So I'll assume he is the judge. He is the judge himself. If and then I'll again traverse through the entire array and see if he is the judge or not. If this guy is getting trusted by everyone or not. If this guy is getting trusted by everyone, then he is the judge. If if there is another guy who's getting trusted, so at that point of time I'll return -1, because that's because that's because I don't know. Initially, I'll explain again. Initially, my judge is -1. So initially, the one who is getting trusted, I'll assume himself, this guy as judge, right? So at my zeroth index, this is first, this is second, this is third. At my zeroth index, the judge will be 3, right? Then I'll go to this one, and I see that the 2 is also trusting 3, right? So my judge is already 3. So there is no need to change anything. Then I'll go here. Again, my judge is 3. So 4 is also trusting 3 and my judge is also 3. So I'll again come here, and 5 is also trusting 3 and my judge is also 3. So at the end, the judge is 3, right? Since judge is not trusting anyone and everyone are trusting judge, right? But this approach doesn't work, because let's say, I have an example like, if you look at this example, you know initially my judge will be -1. So when I come here, I'll have 3 as my judge, right? 3. Then I'll come here, I have 3 and 3. These are equal. So when I come here, I see that my judge changed, right? So at this point of time, we are returning -1. But if you look at this example, you know, here one is trusting 4, 2 is also trusting 4, 3 is also trusting 4, but 4 is trusting no one, right? So 4 is the judge, but we are returning -1. So here 4 is the judge, but we are returning an wrong answer. So this idea does not work. So let's try to jump into the idea of the exact solution. So the second idea that came into my mind is that, you know if you see that if there are n people, the maximum value of n is 1000, right? So at most there can be 1000 people, from 1 to at most 1000. So what I'll do is, I'll create a hash map. Oh, initially the one will be 0. Each and every person will be marked as 0. Each and every person does not have uh, each and every person is not a judge initially. So until 1000 equals to 0. So now what I'll do is, if you observe carefully, there are two major points we need to identify. Suppose let's say A is my judge. A is my judge, and there are some 900 people out there. So all these 900 people should trust A, right? But A should not trust any of the 900 people, right? So this means that when I'm traversing through the trust array, what I'll do is, I'll count how many people are trusting A. If 900 people are trusting A, and if A is not trusting anyone, then I'll say A is the answer. right? Suppose if there are only 899 people trusting A, then A cannot be the judge, right? All 900 people should trust A, right? So in the question we are given n people. So all the n minus 1 people should trust that one person, right? And this one person should not trust anyone. So what I'll do is, suppose if I have A comma B as a array, what I'll do is, this is the guy who's getting trusted, and this is the guy who is trusting B, right? So what I'll do is, I'll increase the trust of B and I'll decrease the trust factor of A. This means that since A is trusting someone, A cannot be judge, right? A cannot be judge uh, in the entire, in the future. A cannot be judged in the future, right? So when A is trusting B, B has the ability to become judge, but A cannot be judge because a judge cannot trust others, right? So at this point, A loses his ability to become a judge, right? So this is the idea, and at the end we'll just traverse through the map again and we'll see which person has n minus one trust. Then that person is the judge, right? So let's go through this example once. Initially we have three people, right? So I'll keep one as 0, 2 as 0, and 3 as 0. And here one is trusting 3. So 3 has the capacity to become a judge. So 3 has 1, but 1 cannot be a judge, right? So I'll keep minus 1. And again 2 is trusting 3, right? So 3 has the capacity to become a judge, and 2 has minus 1 because 2 cannot be a judge in the future. And here 3 is trusting 1, right? So one. I'm reducing 1 from 3 because he cannot be a judge, and I'm increasing 1. So 1 will become 0. So I'll traverse through this map again and I'll see who has two trust points, right? Basically, none of them has two trust points. So I'll return minus 1. If you look at this example, if you look at this example, we have 1, 2, and 3. Initially, they all have zeros, right? All have zeros. So one is trusting 3, right? So 3 will have 1 point. One will have minus 1, and 2 is trusting 3. 3 will have another point, and 2 will have minus 1, right? So again we'll traverse through the entire string and we see that 3 is having two trust points, right? So 3 is the answer. So let's look at the code once. Initially I'm just creating a hash map and I'm putting all the people. Other than we can do something like rush.length. Oh, it's not rush.length, it's n. I'm initializing all the n people with zeros. Then what I'm doing is I'm just going through the trust matrix and I'm taking the array, and this is A1 and this is B1, right? So I'm just reducing the value of A1 and I'm increasing the value of B1. And at the end I'm just traversing through the map again, and if any one of the element has n minus 1 votes, then he is the judge, right? Otherwise I'm just returning minus 1. So if I run this, it's running fine, and I already submitted it. So that's it, guys. If you find the video helpful, then like the video. Thank you.